Hello, friends. So this is going to be a two-part video. Watch both parts. I don't know what this. You know how it is. All right. This one we're going to talk about moon phases just real quick. So if I was you, I would find some note paper, maybe draw this diagram, put it somewhere where you can reference it. Start by drawing in the sun, of course, because that's the light source for the whole solar system, if you didn't know that. Can you see this okay? Is this working? I'm trying. And then, of course, this isn't to scale. Obviously, not to scale. If it was, and this was the sun, I'd have to drive over to Rickers and draw the Earth in about yay big. So clearly, not to scale. Here, we're going to scooch it over just a little bit, maybe. Just see if that helps some. Is that a little better? I think it will be. Hang with me here. So, draw the Earth, of course. And we're going to start by drawing it from above, as though we're looking down at the North Pole. So shade in the side not facing the sun. And of course, label it North Pole. Fair enough. Can you see this okay? Should I bring you in a little closer, baby friend? Ready? How's that? That's a little better. So, remember that at all times, the moon is illuminated on 50% of its surface. At all times. Well, except under special eclipse conditions, of course. But we're going to go with all times for right now. So if it's here, between the Earth and the sun, half of it's illuminated, and the other half is shadowed, just like the Earth. And we call this the new moon. And from Earth, if you could see it, and it's hard to see it because it's aligned with the sun, it would appear like this. This is solid shadowed orb. It has 0 degrees of separation. As it progresses over the next 3.5 days, it becomes more visible to us. Again, half of it is illuminated. But because of our angle that we perceive it, it appears as what we call the waxing crescent moon. And so it's just a sliver of the moon we can see. And this is waxing crescent. Then, after about a week, as the moon continues in its orbit, progressing eastward, again, half of it's still illuminated. But now it appears, from our perspective, to be illuminated like this. We can see half of that illumination now. It's a quarter of the way around its orbit. Thus, they call it first quarter. And it's 90 degrees away from the sun, from our perspective. Follow me so far? Because moon phases are all about the perspective with which we see the moon in its orbit. So now, over the next 3.5 days or so after that, let me add in here. Now we're at 1 week. We're at first quarter moon is about 1 week from new moon. So now we move over here. And again, half of the moon is illuminated, the other half shadowed. But we perceive it to look almost 75% full. So now the crescent's reversed. We see a shadow crescent around the edge of it. And this is what they call waxing, maybe I should say we call waxing gibbous. Waxing meaning it's gaining. Then, about 2 weeks from new moon, oh, that air is a little long. Okay. Again, 50% illuminated. But from Earth's perspective, it looks fully illuminated because all we can see is that lit up disk. And this is called, as I'm sure you know, the full moon. And now it's 180 degrees from the sun. I mean, you can see this, yes? Here's the sun. It's 180 degrees, or halfway around its orbit. And we're about 2 weeks into the process. I say about 2 weeks because the moon phase cycle is 29 and a half days. The moon continues to progress, and in about 3.5 days later, again, 50% illuminated, but now that crescent shadow is reversed. Make it a little more dramatic, maybe. Does that help? Maybe. It's the opposite now. Now we're looking at what they call waning gibbous. Waning meaning reducing. We go another 3.5 days, and we're 3/4 of the way around. Again, 50% illuminated. And from our perspective, it looks like the moon's cut in half with a shadow on the opposite side that it appeared before. And this is 3/4 or 3/4 of the way around in its orbit. And now we're at 3 weeks into the moon cycles. Then it progresses about another 3.5 days or so. Again, the moon's 50% illuminated. But from our perspective, we see that crescent moon again. But now the crescent's reversed. It's on the other side. And this is waning crescent. And then it returns. I hope this is helping. So here's the thing. Because the moon is aligned at 0 degrees, here we're at 180, here we're at 90, here we're at 270 degrees east of the sun. I mean, think about it this way. It's going to be helpful to keep thinking about it as 270 degrees in its completed circle. Here we return to 360 or 0 degrees. And because it's aligned with the sun, it rises at sunrise. I can't believe I just completely misspelled the word sunrise. Wow. Well, you know how I is. So it rises at sunrise here. So if it's 180 degrees opposite, here it rises at sunset. Yes? Does that make sense? Because it's 180 degrees. As the sun's rising, it's setting. As the sun's setting, it's rising. Halfway between those, well, halfway between sunrise and sunset is? That's right, noon. Good. So here it rises at noon. And here, because halfway between sunset and sunrise is midnight. Clever students. I know you guys are super smart. I love it. It rises at midnight. And this is why you see the moon during the day at different times. From this part of the phase cycle, you're going to see it in the morning. And in this part, you're going to see it in the afternoon and early evening. So here it sets at sunset. Here it sets at midnight. And here it sets at sunrise. So here it has to set at, that's right, noon. This is how you can kind of use the moon to tell time and helps us understand the whole cycle process. So I hope this diagram helps, and it will definitely be useful when you do this homework, which I will explain in the next video. See you soon.